Welcome guys, and thanks for tuning into this. Okay, so what we're going to use this video for is just a bit of an opportunity to try and simplify lever systems. Okay, so how can we categorize a joint movement as one of the three levers? We're not going to go into much detail on mechanical advantage, so if you need support with that, please come and speak to someone. We're going to focus on categorizing them. Okay, so a few pieces of basic terminology we need to go through first. Okay, so when we're looking at a lever, there's obviously the lever as a whole, but it's made up of three components. So the first point is the fulcrum, and this is the fixed point where the movement occurs. In the human body, this is traditionally going to be a joint, such as the knee or the shoulder. Okay, the load is the weight that the lever should move. Now, it might just be body weight, or it might be if we're throwing something, it could be the ball, it could be a racket if we're swinging it, a club if it's golf, or a football if we're kicking it. Okay, so the load is the weight that needs to be moved. The effort is where the force is applied to move the load. Okay, so it's not necessarily the muscle itself, but it's actually where the force is applied. Okay, and there is a slight difference between those two terms. Okay, so we can work out which type of lever it is by saying FLE 1, 2, 3. Okay, and what we need to be aware of is if whichever one of these is in the middle, so the fulcrum, the load, or the effort, whichever of those is in the middle will determine whether it's a first class lever, a second class lever, or a third class lever. So if the fulcrum is found in the middle, it's a first class lever. If the load is in the middle, it's a second class lever. And if an E is in the middle, the effort, it is a third class lever. So that's saying FLE 1, 2, 3 will help us to remember that. Okay, so the effort, as I said, it's slightly different to the actual, not necessarily the muscle that's pulling the lever, it's actually where it attaches. And as we know, muscles attach to bone via tendons. Okay, so if we look at the bicep, although the bicep is this side of the elbow, so the elbow's there, it's this side, we would actually say that the effort is applied here on the forearm. Okay, and that changes. So if we were talking about the bicep here, okay, we'd be talking about effort, fulcrum, load. And that would actually make it a different lever, but what we're looking at now is that the effort is attached here, so the load, effort, fulcrum, okay, so that would make it a third class lever rather than effort, fulcrum, load, which would make it a first class lever. So it's very important that we distinguish between the attachment point of the effort. A first class lever then, so a first class lever, the fulcrum is going to be in the middle. That's the first thing we're aware of. Okay, that means that it's going to have the effort and the load either side, and it doesn't matter what order. It doesn't matter if it's load, fulcrum, effort, or effort, fulcrum, load. Okay, just a quick point, this is a simplified lever system drawn. So if you're asked to draw a lever system, this is how it would be represented. Straight line for the lever, triangular shape for the fulcrum, effort is an arrow, and load could be just an object, a block. Okay, and what I want you to do now is just pause this video, take a pencil and a ruler, okay, and set the pencil on top of the ruler, and then if you could just place a weight on the end of it, and that will create a signified demonstration of this. Okay, so hopefully you've made this. Now the distance of the load from the fulcrum is in comparison to the effort and the fulcrum determines how easy it is to lift the load. So if with the one you've just made, if you move the pencil up towards the load, okay, because the effort arm is longer than the load arm, it's actually going to be easier to move. If you move the pencil all the way along to this side and try and move it using just this bit, okay, it's going to be a lot harder to move because the load arm, if that's our pencil there, the load arm is a lot longer. Okay, so a first class lever can have mechanical advantage or mechanical disadvantage. Just depends on which arm is longer, the load arm or the effort arm. If the effort arm is longer, it's going to have a mechanical advantage. Spotting examples of this then. Okay, because the tricep attaches to the elbow at this point here, so it's behind the elbow, yeah, we have effort applied here, we have fulcrum here, and we have load here. So the fulcrum is found in the middle. Okay, that makes this a first class lever. Likewise in the neck, yeah, the joint would actually be here, so the bone would be here. Okay, load could be here, load, fulcrum, and then the effort of the muscle attached here. Okay, so heading a football and taking a throw in or a line out in rugby, tricep extension are very good examples of sporting examples for the first class lever. Pause that there, make a few notes on that, and particularly get used to drawing out these diagrams. Have another little play with the model you've made as well. Moving on to second class levers then. So for a second class lever, we are going to have the load in the middle with the fulcrum on one side and the effort on another. Okay, again, drawn in our simplified diagram, fulcrum, effort in the middle and load. Load in the middle and effort on the side. And like I said before, it doesn't matter if the fulcrum's on this side and the effort's over here, as long as the load is in the middle. The distance of the load from the fulcrum will always be less than the distance of the effort from the fulcrum, meaning it has a mechanical advantage. Because the load's in the middle, fulcrum's always going to be on one side, the effort always has to be further away from the load to make it in the middle, therefore has mechanical advantage because it takes less effort to lift it because the effort arm is longer than the load arm, and you can see that in this diagram. So quickly draw that one down. And that's quite true. If you think about why we use wheelbarrows, we can lift a heavy load in a wheelbarrow because the fulcrum is where the wheel makes contact with the floor. The effort is applied by the human using the wheelbarrow, and the load is in between the two. And you think about how much heavier a weight you could lift with a wheelbarrow in comparison to just carrying it in bags. So some sporting examples of this then. Your calf causing plantar flexion is actually a good example of a sporting example. Yeah, so we have the fulcrum, then we have the load, and the effort is attached on the back of the heel here. Okay, so because the distance from the fulcrum to the effort is shorter than the fulcrum to the load, although there's load all the way up here, we consider the load to be there, much easier to project that. And if you think about doing calf raises compared to squats, you can actually calf raise a lot more than you can a squat because that ankle movement is a second class lever with mechanical advantage. Likewise, a press up is also a second class lever. Fulcrum is the point of contact with the floor. The triceps and the chest, which are going to do be the effort, and the triceps attach here. Okay, and the chest is here, so in the arm. Okay, and the load starts here because it's a whole body movement. Make a note. Okay, now finally one, a third class lever system then. So effort is obviously going to be in the middle with a fulcrum and a load either side. Okay, and again, we could draw this in any order, but we've got load, effort and fulcrum. Now converse to a second class lever, with this one we're always going to have a longer load arm than the effort arm, with the effort arm being in the middle. So this means we have mechanical disadvantage. Okay, so it's always going to take more effort to move this than if it was a second class lever. Okay, so it requires a greater force. But it can generate high speed. So if you look at this example here with the fulcrum between the ruler and the finger and the thumb being the effort, if you think about if you were to try and flick this object for a distance, yes, it's going to take effort, and the further you move that thumb in, the harder it's going to be to lift this, or the further you move that back. But if you think about an old-fashioned catapult, although it takes more effort to shift it, it's actually going to generate a really high speed. And that's true with the body. If you think about long bones, yes, it takes effort to move them, but the reason we can kick a football so hard is because it's such a long lever and it can generate such high speed. So sporting examples of this would be the knee joint. Yeah. Okay, so we've got the fulcrum here, got the effort attached below the knee and the patella tendon, and the load is the foot, which is going to kick the football. Okay, so it can generate a high speed, but it's mechanically disadvantaged. Pause that, make some notes. Okay, so a little exam question for you. If you pause this, spend 3 minutes to do it because it's a 3-mark question. The image shows a rugby player, so you need to name what lever system it is and draw that one out. Now, it's an example we've looked at in the video, so we should be well rehearsed. Pause it there. Okay, so you may have worked out but it is a first class lever system, and that would get you 1 mark. You would then get a further 2 from being able to label it correctly, okay? So we've got the effort here, which relates to the tricep attaching beyond the elbow. Okay, the fulcrum is the elbow in the middle, and the load starts back here behind the head. And that's how we do a line out. Could have put this in reverse order, that's not a massive issue, as long as the fulcrum's in the middle and the other 2 bits are correctly labelled.